This was the drag struts, and here the torsion link which connected this and this together so that it move without do not move rotate inside it, or do not rotate without any unwanted motions, to avoid all unwanted motions. Okay, so let's start. As usual, from here we choose part design, and after that we have to choose that body, create a body, and then sketch. It is opening little, taking a little bit more time. Yeah, from here create body and then create sketch. I'll take this plane. Here I will take polyline. Let me check it. This is half section or cut section of the piston leg. This is solid and this is empty. After rotation, this will make it. Okay, so let's define some verticals here. Okay, and those which are horizontal, this one, I have to zoom it, this one, this one, zoom out, zoom in, and this one. Okay, now this would be like this. Okay, this is more and this is very less. So let's give some dimensions to it. First, I'm going to give a vertical dimension from this point to this point. We are showing 18 mm total length. Let it be 20 mm. Okay, so now this length would be 6 mm and this would be 3 mm. Okay, so this is 0.5 mm. This is less 0.1 mm. Let it be. Okay, here is it. Now I will give this one 2.6. Let it be 3 mm. Okay, -0.5. All the dimensions are given, so I will place them accordingly so that it do not create any mesh. It is completely complete. Just I will fix this point to this so that it won't move and fully defined. After that it would be fully defined. No. Yet we have 1 degree of freedom. Let us check which one. This one. This length. Okay. This length. We haven't fixed this yet. Okay. Let's fix this vertical distance 0 and let it be. Okay. Now it is fully defined. I can also change it to 0. This would be fine. Okay, now I have already auto update is on, so no need to update. Just close it. When it is closed, isometric view, and here I will choose revolve like this. Okay. Now here you can see this one like this. Okay. Here you can see this. This is hollow but solid from that end. Isometric. Okay. Now here we have fillet on this edge. 1 mm is too much. 0.1 mm would be fine. So 0.2 mm so that shape do not distort it. Okay. I guess length is too less. We need to increase this length. So what we will do, go in this revolve. There is a sketch in our tree. This length we will change to 30 and close it. Now zoom to fit at this. Now it is looking fine. Okay, here would be our cylinder. Inside this, here we need some that parts. Okay, for that I need position that explain explain and sketch over this. Here I will make circles. Yes, here is a circle and I will make this circle here. Okay, I am taking it a bit away. If I could able to, so I can't see this. Let it be this size. Close and pat that circle. Okay, symmetrical and increase the distance. Let it be 20. That is 5, 10 here and 10 there equally. Okay, now I can change this sketch and increase the dia, placing it at the center. Here, horizontal distance would be 0. Okay, vertical distance was fine. We now need to change it, giving radius 0.8 it is showing, let it be 1 mm in close. Now it is fine. Okay, we can see this. So fine, both sides are equal. Now what we need to do with this, taking this plane and making a sketch over it, increasing, make a circle over here. Okay, giving it a radius that was 1, so it would be 0.9. Okay, fixing it here with this, the horizontal distance would be 0. Fine, vertical is looking fine. Now need to give it closing, and that sketch will pad. I would like to say it as an isometric view, not 5, 1 mm. Where it is cutting. Can you see that? Let's cancel it and pad it. Yeah, here we can see that we don't need time. We need 2 mm is enough. Okay, this is for the ball joint. Ball joint will be fixed here, and after that, get housing of ball joint. Now I will do one thing. Select this pad and mirror it about the display. About display. Okay. Let's see in isometric. Yeah, both side we have made that. I was trying to make it. Okay, This is fine. Now what left? Here this section, that triangular part, this one, like this. Okay, let's make that also. That would be YZ plane, YZ plane, and create a sketch there. Let's make it with the help of this one. That is our polyline. Here to here to here and join it. I guess it's not joined. Let me check. No, it's joined like this only. We don't need any. Okay, now I will close it and pad it. Not that much. I will plan 1 mm in symmetric manner. Okay, so fine. I will select this, mirror it about front plane. Okay, now again go to isometric view. Fine. We have both these ports. Yeah, we I this thing is lesser, that's why it is like this. In that figure, this portion is a bit longer, that's why it is this angle was little bit more. But this spot is between these handles and at the end point of this only. So I make it like this. Okay, as when we have all the dimensions and all the everything we have, then it would look much better. So we have done with this. Now what next? What we are left with, that I guess that drag strut, dot hole and torsion link hole here. So let's make torsion link hole here only. That would be set by plane, sketch on it. No, here we can make that torsion link, I guess. No. Here we are going to make that triangular torsion link hole. Okay, I guess it won't make it here. Let's try. Let's not make presumption first. Here again that polyline, making this line, this, joining it there. I'm taking it away so that I can make it what I similar to what I want, what we need. After making that I will fix it to the cylinder. Okay, as this line was not visible behind this, that's why I have taken it out. I will make it here, hold this shape, and then fix it near on this, or near this, or on this, as we need on this over this. So I will place it over this. Here we need this one. The radius of this would be 1 mm. Let it be no 0.1 mm. Yeah, it is fine. It's looking good. All fine. Okay. This one. We can move it like this. Okay. Here we made it. Now this circle would be there. That is whole of. I need to give it a vertical dimension between these 2 points. That is 0. Okay. I'm not going to define it fully as we don't have any dimensions. I don't know how much up we should be, how much down from here, but dimension I should need. I, I am making it as it is looking fine. So close it and pad it. 2 mm symmetric. Let's see it from this side. Looking fine. And what is from here? I can change it. 3 mm is fine enough for us. Okay. Now we can see it as isometric. It's fine. Okay. Now we are left only with that drag strut joint here, which is also on the YZ plane. Sketch and make 2 circles here. No, it is not on that YZ plane, it is on other plane. So delete it and close it. It is on exact plane and sketch it over. Here it would be. I think I have to get taken datum plane over here. Here we'll take a plane, cancel ZX and play. Okay, looking at from right view. Now it would be increase in Z direction. Here it is fine. Okay, now on this plane I will sketch, but I will sketch it two circles joining it. That's it. Okay, and this one place over here. Close it and pad it. Now 10 mm. Just 2 mm is enough for now. Okay, here isometric view. We'll hide this by pressing spacebar. Okay, this is how it look like. Yeah, this thickness is and all that are looking so rough and not symmetrical, but we don't have any dimensions, that's why it is looking like this. Otherwise it, it is fine. You can say this. You want to see it from this side like this. In that figure it is like this. It is showing like this. You can see this. These and these are perpendicular to each other. You can see here also this and this is perpendicular, and similarly I have made this perpendicular to each other. Here it is a isometric view. At that end I have made this on over this side. That's why it is that is looking like something different, but it is similar. You, we can have it here or here depending upon our dimensions and requirements. When we have dimensions, we also have the location where to place this torsion link joint and drag stud joint. This is how it is made. Now here would be ball joints. Then housing of that ball joint here drag stud would be connected to main aircraft, and that after that the here would be pneumatic cylinder and piston. Here the torsion links and piston inside this with another torsion link, and those torsion links are joined to each other. And on that piston head down there would be wheel assembly. And this is how we have completed our landing gear. All the components are completed and this landing gear is complete. And next class we will take some other part or another component of this. And that's all for now. And today our landing gear is finished with this. Thank you.
Thank you, sir. Thank you.